Hey, what's up? Gleb Alexandrov here for CreativeShrimp.com, and welcome to yet another very exciting Blender tutorial. Today we'll be dealing with the paint splash effect, and this will be very fun. I promise you'll learn a thing or two about particle systems, force fields, metaballs, and how you can combine these techniques in Blender to create astounding paint splashes. Oh, and also we'll explore the awesome principled shader that was added to Blender 2.79. So keep watching, subscribe, and let's jump straight in. Let's start off by creating a smoke simulation. It may seem a little bit weird, but we'll be using smoke simulation to guide our particle system. And if your Blender looks different, it's because I use soft blend theme. You can change it in the Blender user preferences. Alright, we have a cube here, and what I'm gonna do is set the maximum draw type to wire. This will be one of the objects of our smoke simulation. Let's go over to the physics tab, click on smoke, and select flow. Smoke simulation needs two objects, flow and domain. So let's create yet another cube. Go to the object properties, set the maximum draw type to wire once again. Let's also align these two cubes in the center of the scene, something like that. And in the physics tab, I'm gonna click smoke and select domain. Hooray, we created a basic smoke simulation. We can test it out by pressing Alt-A to play the animation. And it works, definitely. Let's now select the flow object. And to keep track of things, I'm gonna name it flow. And I will select the second one and call it domain. So I selected the flow object once again. And the physics tab, I'm gonna decrease the density just to be able to see through the smoke. Let's play the animation again by pressing Alt-A. Now, we won't need the smoke to rise, so I will set the temperature difference to 0. If we now play the animation, we will see that smoke sticks to the object. Alright, step 2 of this tutorial is to create a particle system. The idea behind all of this is that we use our smoke simulation to guide the particles. So I created yet another cube, and I'm pressing Ctrl and 1, 2, or 3 to set the level of subdivisions. It automatically adds the Subsurface modifier. Let's apply the modifier to get it out of the way. Go over to the Particles tab, press New to create a new particle system. Let's call it Particles. And the number of particles, let's maybe set it to something like 50,000. In the object properties again, let's set the draw type to wire. Press Alt-A to preview the animation. So that's a very basic particle system that is being affected by gravity and which has some velocity on birth, and we don't need it. But first of all, I'm gonna crank up the life of particles so they don't die at 50. Let's set it to 500. And we can also define when the particle system stops spawning the new particles. I will set it to 80. The emitted geometry, 0. No more velocity. And if we now play the animation, we will see that it just falls down because the particles are still being affected by gravity. Let's remove it from the equation. Go to Field Weights menu and reduce the gravity slider. Now the particles are just gathering on top of the sphere. And that's definitely a good starting point for what we're gonna do next. And we are going to add the turbulence force field. This force field will help us to shape the smoke and then shape the particles. Let's go Shift-A, force field. Blender has a bunch of different force fields. Let's select turbulence and rename it to turbulence right away. This force field creates a 3D noise which affects the behavior of particles. You can change the strength of it, the size, and so on. But for now, let's just press Alt-A to preview it. And you can see how the turbulence force field warps the physics of the particle system. That looks maybe like an Obscurus from Fantastic Beasts and Where to Find Them. Let's set the size to 1. In other words, let's increase the scale of the turbulence field of the 3D noise, which bends and warps the particles. That looks very interesting. Let's crank up the strength, set it to 15. And the other option that we can change is flow. Let's set the flow to 5, and now you will see that the particles are starting to flow along the curvature of the 3D noise. And I guess everything that makes it look more like a liquid is good, because we're aiming at creating the paint splash effect. Without this flow parameter, it's a little bit on a spiky side. Alright, and maybe I will crank up the size of the noise a little bit more to make it smoother ultimately. I think it looks good already. I'm so fascinated with force fields and particle systems and physics. Now let's add the smoke flow force fields. That is the key element of this tutorial. Before adding the smoke flow, I will set the turbulence influence to 0 in the field weights menu. I'm doing this because I want the turbulence force field to affect only smoke and not the particles itself. See, the smoke is pushed around by the turbulence. And by the way, one more thing that we can do with the smoke sim is increase the resolution or decrease it. For example, if we double the resolution, we make it slower, of course, and also more intricate. I'm not sure that I like the additional details here, so I will set it back to 32. And the next step is to add the smoke flow force field. Shift A, force fields, smoke flow. What this force field does, it essentially makes the particles conform to the flow of the smoke simulation. That's a very cool way to drive the particles using the smoke sim. That's crazy. We can crank up the strength of the smoke flow, and oh, I forgot to pick the domain, it seems. So in the domain object, click on this eyedropper and select the domain object. And now watch the real magic happening. Alt A and I have never known that I love particle simulations before I tried that thing. I mean, it's really mesmerizing. Right, let's set the flow to 2 to make it a little bit more liquidish. Does this word even exist? Liquidish. The next thing we can try is increase or decrease the size of the flow object, and that will affect the look of the whole simulation in a big way, because it will interact with the turbulence field in completely different way. Just look at this, it's like an exploding star, something along these lines. Or maybe it's a fluid, but in vacuum. Or it just exploded, because it happens, you know. It's a bug, nothing to worry about, and if we make the flow object very small, particles will take shape of this, I don't know, spaghetti thing, or a sea creature of some sorts, and I'm aiming for a little bit different effect, so I'm trying to search for it. For example, here I'm trying to increase the divisions of the smoke simulation, and I don't know yet if it helps or not, because it's back and forth, jumping between different settings and trying to find what works. Before actually recording this tutorial, I made some experiments and tests, and each time I tried it, I got completely different result. So here I set the strength to 15, and it helped a lot. And a little bit higher flow will also help, I think. So let's do that. The whole idea is to get to the point where it looks like a paint splash frozen in time. And actually, I think these settings are working pretty good. The next thing is to animate the flow object. I would say it's an optional step, but still it's good to know. Well, we can animate any parameter, but to keep it simple, I will just take the location of the object, and we can move it like this, while playing the animation. I think that's amazing. What I'll do next is sample 3 or 4 keyframes. Maybe let's create the first keyframe here by pressing I and selecting location to create a location keyframe. Let's move it over here, press I again, select location, jump to frame number 40 and create yet another keyframe. You got the point. Sometimes it's very dangerous to animate parameters in a smoke simulation and in particle simulation because you can quickly lose track of what's going on because there are so many things interacting. But now it looks like a meteor streaking through the night sky and leaving a trail of a manga-style particles. I don't know. I'm getting a little bit overexcited, I admit it, and it's not about coffee or something like that. I feel like a particle physicist of some sort. And if you want to change the length of the animation, you can open the dope sheet, grab these keyframes, press S to scale it up, to spread it out, I would say. And after you did it, let's go back to the 3D viewport. Preview our simulation and animation by pressing Alt-A. And once again, what's going on here is the particle system that we created and the smoke simulation that we created. They interact. In brief, particles are following the smoke. Okay, one more force field that we can experiment with is the vortex field. I will show you how to do it very quickly. Shift-A, force field, vortex. And it's very important where you place the vortex object in this scene, because it will serve as a pivot point for the vortex effect. And in the particle object, I will turn down the vortex influence. Again, I don't want the particles to be affected by the force fields directly, just the smoke. And then particles follow the smoke using the smoke flow force. I hope that still makes sense. Right now you can see the microscopic tornado in the viewport. To get even more fun out of it, let's increase the strength of the vortex. Watch out for Dorothy flying with her house, I don't know. And I honestly think that this effect would create a nice basis for a tornado or something like this. Vortex plus smoke simulation plus smoke flow force field which affects particles. But for now, I will delete this vortex force field. It totally makes sense to use vortex to create a circular pattern of a paint. But let's keep it simple, because it's already very complex. Now I will do the final tweaks to the particle system. After we are satisfied with the look and feel of the particle simulation, we can increase the number of particles. We will be using Metaballs a minute later, and Metaballs love when the particle system is densely populated. Okay, for now I will hide the smoke domain and the smoke flow object by selecting them and pressing H. One thing to note is when you hide something, like the smoke simulation, it still affects the rest of the scene. You just don't see it. So here is our particle simulation with 500,000 particles. And by the way, this video is sped up. The original simulation was much slower. Of course, I recommend you to choose your own number of particles based on how strong your computer is, because it may probably burn. Okay, folks, now let's unleash the Metaballs. Metaballs is a wonderful feature of Blender. Let's go Shift-A, Metaball, Ball Metaball, whatever it means. What I'm going to do now is select the particle system, jump in the render settings of this particle system and select object. Now we have to pick the object that will serve as a particle, and I will pick the metaball. When two metaballs appear near each other, they merge. And so we get this mesh. And when we use it with the particle system, which has 500,000 particles, it can get very slow. So when I want to scale metaballs, I press S, then 0.5, for example, to make it 2 times smaller. Or I hit the S key and press 2 to make it 2 times larger, and so on. So I made the metaballs much smaller, and now I want to increase the resolution of metaballs. And it works this way. If you want to double the resolution, you go the other way, you halve the resolution. Because 0 is the highest res, 0.1, for example, is very high resolution, and 1 is much lower resolution. I think 0.1 will provide us with enough geometry to work with, and the viewport got sluggish. I can cope with it for sure, but it's not a very enjoyable experience, especially if you have a weaker PC. And don't forget that we still have the particle system underneath. So we can jump to different frames and check the different stages of the simulation to see what gives us the best result for paint splash. And let's set the matte cap in the viewport to something more painterly, I guess. And the next very important step is to hit Alt-C and convert to mesh. Basically what it does, it collapses the mesh created from Metaballs to just the good old polygon soup. So we created the particle system, we used Metaballs to mesh it, and we converted it to a simple polygon mesh. Let's now do 1 or 2 additional particle simulations. Just to add the tiny details and stuff like that, I'm gonna make the flow object smaller. It will do the trick. It will still follow the same turbulence pattern, but the result will look slightly different because of the smaller size of the flow. And by the way, that sphere bothers me because we converted it all to mesh. And this sphere is also a mesh, it's not a Metaball, so I'm gonna delete it. I will hit B, draw the rectangle, hit X and delete all vertices. Now let's create yet another Metaball for the second particle system. Select this particle system, go to the Duplicate Object tab and select this newly created Metaball. In the Metaball settings, let's reduce, or rather increase the resolution by reducing this number to 0.2 or even to 0.1. And obviously, when you step up the resolution of Metaballs, you greatly increase the poly count of the scene. It can quickly get out of control. Alright, so let's convert it to mesh by pressing Alt-C and selecting mesh from Curve, Meta, Surf. It's a very useful hotkey in many situations. Now I'm gonna delete this sphere again and do the same set of procedures for the third object. Only this time I will delete the keyframes to achieve a little bit different result. Set it to frame 0, press Alt-I, delete the keyframe, and do the same for the next frame, so to speak. And for the rest of the frames, Alt-I, delete keyframe. Now we can move it roughly to the center of the splash object, something like this. And I think it would be nice to bring back the turbulence influence on the particles themselves to see what kind of effect it will produce. Also, while I'm testing stuff, I tend to set the number of particles to a much lower value, and the result looks a bit weird. Let's remove the smoke flow from the equation and see what it gives us. And now we see 2 tiny hands and the rest of the Cthulhu. Damn, it's awesome. I think it will work great as the tiny droplets. Now let's just repeat this stuff with Metaballs and bring back the emission number. And we are good to go. We have 3 particle systems meshed with the help of Metaballs, then converted to the usual mesh objects. I think it's a very interesting way of modeling things using particles. It's not very obvious at first how to model stuff like paint splashes. Should I use fluid simulation? That's the first question. And sometimes, as you can see, we can get away with not using liquid sim, because in the end, it's about tools. It's about tools that produce certain results. And if smoke flow plus Metaballs plus whatever gives you the same kind of thing, maybe it's the right tool for the job. And the same principles are applicable not only to Blender but to every piece of software. And by the way, what other software has Metaballs? Maybe ZBrush has Z-spheres, yeah. If you know any other software, let me know in the comments. Okay guys, the next step is to add the smooth modifier. The smooth modifier really sells this effect. Okay, so let's isolate the first object by pressing / on the numpad. Now add the smooth modifier. We can try to crank up the factor but because our mesh is a mess, it will not give us what we want. Instead, let's turn up the number of iterations. Let's set it to 10, 11, maybe as high as 50. Whoa, it's great. Yet another modifier that I think will work very well with the smooth modifier is displace. We needed to bring back some of the thickness of the initial model, so I'm going to set it to something like 0.1. Also, if you look at the paint splashes references, you will notice that they're a little bit bulky, not very thin. Okay, I'm going to do the same steps for the rest of the models. First, apply the smooth modifier, crank up the number of repeat iterations. After that, apply the displacement modifier to make it more chubby. Next, I will sculpt the meshes, because I think it will benefit from a minor artistic intervention. Let's jump over to sculpt mode. Before any sculpting, we need to apply the modifiers. Now press T to invoke the left tool shelf. And we can try different brushes, like a snake hook brush. It's fun. Kind of silly, at least without dynamic topology, but I don't want to mess with topology right now, so I will just select the grab brush and shape this thing a little bit. You can increase or decrease the size of the brush using right and left bracket, but a really cool brush to use is the inflate deflate brush. As its name says, it allows to inflate or deflate polygons, so we can create these droplets at the end of these tendrils, tentacles, whatever. It's a minor detail, but if you check references, you will see it literally everywhere. It seems that it really helps to sell the liquid feeling. Maybe somehow relates to the surface tension and to physics of liquids, stuff like that. It makes it look believable, and that's a good reason to do it, so that's why we sculpt after meshing, to add in the details that really helps to take this simulation to the next level. Alright guys, let's now set up shaders and lighting. Jump to the Add menu, add camera first. You can press Ctrl, Alt, and 0 on the numpad to align this camera to the active view, and maybe increase the alpha of the passpart 2 of this camera. Okay, I split the window in two because I want the top window to be the node editor, and I'll put the bottom window in the rendered mode, so it will show the cycles rendering. In the render settings, make sure you use GPU compute if you have video card. I will also set the number of bounces. Diffuse, gloss, and transmission bounces to 2. And I think it's maybe a little bit too high because 1 will work in this case. But I really want this second glossy bounce for no particular reason. Okay, and in the environment tab, click on Use Nodes. And let's make the environment white. I envision this as red and white kind of color scheme. So let's open the node editor, create the new material, and call it red material. Surprise. Here we have the diffuse shader. Let's set it to red to just approximate how it will look. And if you want to assign this material to all the objects, what you can do is select everything, then make sure that the active object is the object with this material, red material in our case. And then click on this icon and select copy material to others. And bam, we assign this material to all objects. And I will tell you, one thing that I'm really excited in this tutorial is the principled shader. It was added to Blender in 2.79, and it's amazing. It's like an Uber shader that combines glossy, diffuse, transmissive, subsurface scattering components and so on. Let's just plug it into the surface output. pick the reddish color. I already see some specularity going on. We can crank up or decrease the specular component and also the roughness. I will take it down quite a bit because this is liquid after all. By all means, it should be highly reflective, very glossy, almost mirror-like, and to better see all these properties and to add some depth to it, I will add the area light. Increase the size. Because, it never hurts to add some directionality to your lighting setup. Ambient lighting, obviously, can make objects appear very flat. And to add some extra dimension to work, make sure you have a dominant light source. And it reads very well. Too many lights is also a bad thing. One dominant light source is alright. And every other light source is practically a fill light or a rim light. Classic. Okay, and what I'm trying to do here is not get overexcited with the light strength. I try to keep it very subtle. And now is probably a great time to experiment with the look of this thing. Maybe you would like to turn it into a green blob, and it will look gorgeous. But I really like the red liquid. Not only because it triggers a dopamine response in your brain, that is only a part of the reason. And not only because it's deeply ingrained in our physiology and stuff like that. Pretty much all cultures around the world develop red color after black and white. Alright, let's add the mix RGB node and mix red with the adjacent color, like purple. And one cool thing that we can do is use the normals of the mesh as a mix factor between these two colors. So let's add the geometry node, the normal node, plug normal in here, and add the color ramp after that. And we will hook this setup up to the mix factor. What it will allow us to do is basically to take the normal of the surface and reveal the second material based on this normal. Here I'm clicking this sphere and I'm dragging, and you can see how it affects the look. We can move the flags to affect the fall off of this effect. I don't want to go overboard with this effect, I just want to add a little bit of variation to the colors. So I will pick a peachy color to add a nuance to our original lipstick red. Or maybe to hint at a subsurface scattering. That could be the case here, a little bit lighter red. And one more thing that I will do with the colors is, first of all, I will duplicate the mix RGB node. Then I will go input and add the Fresnel node and use it once again as a mix factor between these colors and some other color. For example, let's take blue just to demonstrate the effect. The Fresnel node will make the second socket of the mix RGB node appear at a glancing angle. It's very useful for imitating the additional reflections. So let's use it and pick an orangey color. Again, I'm trying to not overdo this effect so it gets straight in your face. It's a lot better when it's nice and subtle. If you choose red as your main color, it just complements the red. Okay, and the next lovely thing is subsurface scattering. Principled shader has built-in subsurface scattering. What it does, it simulates the scattering of the light rays beneath the surface of the model, just like our skin is red because underneath the skin is a red meat. Sounds creepy. Hello. And the subsurface radius parameter governs how deep the light rays go. So I will set it to 2 and leave a subsurface scattering at a higher value, I think. Or maybe not, but it will have at least some subsurface scattering. In my opinion, it should have at least some, because if it's an oil paint or stuff like this, it's highly reflective, but still you can see the light scattered inside the paint itself. I think it's totally reasonable for colorful liquids to have high subsurface scattering. Feel free to experiment with it. It's very amusing just to play with this shader. And the next thing is tone mapping. We are dealing here with a highly reflective stuff which shoots the luminosity values through the roof, so we'd better set the tone mapping to filmic, because it handles the high dynamic range really well. And to regain the contrast, I will set it to the very high contrast mode, or even set the exposure a little bit higher. It's already a little bit on the extreme side, so be very careful. While I was tweaking the values, I got an idea that maybe it would be cool to introduce yet another color. How about a white color to create milk and strawberry shake, something along these lines? Let's try it out and see how it works. Select one of the objects, jump into the Materials tab, press this plus icon to create another material based on the material 01, and I will call it white material. Jump into the node editor, and funny thing, I will leave the subsurface scattering color at red and change the base color. So it will have a monochromatic base, but at the same time it will possess a reddish tint caused by subsurface scattering, which is red, which approximates that the underneath this white surface is meat. Oh my goodness, that's getting creepy. Really creepy. Stop this, Gleb. Awesome, we're almost there. The last thing that we're gonna do is just render it out. Now it's a good time to reposition the camera if you want to produce a static shot. I selected the camera, then placed the 3D cursor onto the model, pressed R 2 times to rotate the camera around it. That's a very easy way to orbit your camera around the model while searching for the best shot you can get. The next step would be to set up the render settings before hitting this magical button. Let's move to this tab and make sure that everything is set up correctly. Let's crank it up to 3 bounces. Reflective caustics and refractive caustics is on, and I'll set the render samples to 512, just to make sure I have a relatively noise-free render. I will set the dimensions to 1912 by 1080 pixels, 100%, and hit render. And it renders some kind of Silent Hill. If that's your intent, go ahead. But maybe something went wrong, and I guess I know what went wrong. Let's select every object, press M, and move everything to layer number 2. Because we still have a smoke simulation lingering around in layer 1, let's leave it there and just click on layer number 2. As usual, hit render button, hope for the best, and after you render the image, you may realize that something is off about it. In this case, maybe it needs another level of subdivision, because you can see there's jagged polygons, and that's probably not a very good thing when it comes to liquids, but if you crank up the number of subdivision surfaces, the poly count, and it's right now 1.5 million faces, will skyrocket. It will get much higher, so keep an eye on the poly count. And if your computer allows you, add another level of subdivision. It will make everything much smoother, and potentially it can be very beneficial for this liquid look. And the last thing that drives me nuts is this protruding part. What I'm gonna do is use the inflate brush to create this pimple. It's always good to keep reference images nearby so you can evaluate your work. After you get it done, go to the object mode, and probably the last thing, if you want to cut the render times, it would be cool to use the built-in denoiser. Go over to the Scene tab, enable denoising. I won't do it right now, but if I were creating animation, it would be way to go. Alright, but now I will just set render samples to 512 and hit the magical button. It's rendering. It concludes the paint splash effect tutorial. Woo! Woo! I hope you enjoyed the tutorial. My name's Gleb Alexandrov. You're watching Creative Shrimp YouTube channel. And as usual, feel free to share this video with other nerds because it is really helpful. You help me a lot. Share, subscribe, and leave a comment below. That's a holy trinity of... That's a sort of a... Have fun with paint splashes. Stay tuned and take care. Metaballs. Metablobs.